In the forest, failure isn't an option. No roads, no service trucks, no second chances. That's why in the 1980s, skidders weren't designed to be smart. They were designed to be unbreakable, massive frames, torque-heavy engines, drivetrains strong enough to drag trees bigger than houses. Decades later, while modern machines struggle with sensors and shutdowns, these old skidders are still out there, pulling giant timber through mud, snow, and steep terrain like time never touched them. Today, we're counting down the 10 skidders from the 80s still pulling giant timber, the forest beasts that refuse to retire. Get ready, because this is raw logging power at its finest. Number 1. Caterpillar 528 Skidder. The Caterpillar 528 skidder represents everything that made 1980s logging machines legendary: brute strength, mechanical simplicity, and an almost reckless level of over-engineering. When Caterpillar designed the 528, they were not trying to build a fast or comfortable machine. They were building a skidder for loggers who worked in steep terrain, deep mud, frozen ground, and forests filled with stumps and boulders. The expectation was simple. This machine would be overloaded, slammed into obstacles, and worked for long shifts far from any workshop. So Caterpillar built it accordingly. At the heart of the 5028 was a naturally aspirated Cat diesel engine tuned for low RPM torque rather than high horsepower. This design choice dramatically reduced internal stress, allowing the engine to run cooler and last longer. In real-world logging, that meant operators could pull massive log turns without worrying about overheating or catastrophic engine failure. The drivetrain was equally brutal. Axles, differentials, and drive shafts were oversized to absorb shock loads when logs snagged on roots or rocks. Sudden jolts that would destroy lighter machines were simply part of daily life for the 5028. The frame is where the 528 truly earns its reputation. Thick steel plate construction protected vital components, and the articulation joint, often a weak point on skidders, was reinforced to handle decades of twisting under load. Forestry guarding was extensive, shielding hoses, lines, and the engine from falling timber. Hydraulics were intentionally slow and conservative, prioritizing durability over cycle speed. Lower operating pressures meant less heat, fewer leaks, and far longer seal life. Even today, many Caterpillar 528 skidders from the 1980s are still working, often with rebuilt engines but original frames and drivetrains. Their continued operation proves that Caterpillar's old philosophy, build it heavier than necessary, was exactly what logging demanded. Number 2. Timberjack 460 Skidder. The Timberjack 460 skidder is often remembered as one of the most perfectly balanced skidders of the 1980s, and that balance is exactly why so many are still working today. Timberjack had a reputation for listening to professional logging crews, and the 460 reflects decades of real-world experience rather than theoretical engineering. It was designed to pull massive timber efficiently while surviving the abuse that comes with daily forest work. Powering the Timberjack 460 was a deliberately under-stressed diesel engine that delivered steady, predictable torque. Timberjack avoided chasing peak horsepower numbers, instead focusing on drivability and longevity. This allowed the machine to pull heavy log turns without excessive strain on the engine or drivetrain. The cable winch system was one of the strongest ever fitted to a skidder, with thick drums, oversized gears, and powerful braking systems capable of holding enormous loads on steep slopes. Structurally, the 460 was built to resist fatigue. The frame was heavy but well balanced, preventing excessive flexing that leads to cracking over time. Axles and differentials were reinforced to absorb shock loads when logs suddenly caught on terrain. The articulation joint was engineered with durability in mind, allowing controlled movement without excessive wear. Hydraulics were simple and reliable, designed to operate in dirty environments without constant failure. What truly sets the Timberjack 460 apart is longevity. Many units built in the 1980s are still pulling timber today, often with multiple engine rebuilds but original frames and winches. Operators trust these machines because they behave predictably and can be repaired with basic tools. The 460 proves that thoughtful, experience-driven engineering creates machines that outlast entire generations of newer equipment. Number 3. John Deere 648E Skidder. The John Deere 648E skidder, introduced in the late 1980s, marked a turning point for Deere's forestry lineup. It was built specifically for heavy timber operations where lighter skidders simply could not survive. Deere engineers took everything they had learned from earlier models and applied it to the 648E, creating a machine that emphasized durability, traction, and rebuildability over speed or operator luxury. The engine in the 648E was tuned for strong low-end torque, ideal for dragging oversized log turns through difficult terrain. Deere avoided pushing the engine to its limits, which reduced heat buildup and extended service life. Cooling systems were generously sized, allowing the skidder to work long shifts without overheating. The drivetrain was designed to handle shock loads, with heavy axles and reinforced driveline components that could absorb sudden impacts when logs snagged on stumps or rocks. The frame of the 648E was heavily reinforced, especially around known stress points such as the articulation joint and winch mounting areas. Forestry guarding protected hoses, fuel lines, and critical components from damage. The hydraulic system was straightforward and durable, with minimal electronics, making field repairs possible even in remote locations. Deere understood that downtime in logging is expensive, and the 648E was built to minimize it. Many 648E skidders from the 1980s are still in service today, particularly in regions with large timber and tough terrain. Their continued use highlights Deere's commitment to building machines that could survive decades of abuse, not just a few years of warranty coverage. Number 4. Franklin 170 Grapple Skidder. The Franklin 170 Grapple Skidder is one of the most unapologetically heavy skidders ever built, and its 1980s models are still legendary for their sheer toughness. Franklin's design philosophy was simple. If something might break, make it thicker. The result was a skidder that relied on mass, steel thickness, and conservative engineering rather than finesse or efficiency. The articulated frame of the Franklin 7T was constructed from thick steel plate, designed to twist under extreme loads without cracking. The grapple system was enormous, with oversized arms and hydraulic cylinders capable of grabbing and dragging massive bundles of timber. Hydraulic pressures were intentionally conservative, reducing heat and extending component life. While this made the machine slower than modern skidders, it made it nearly indestructible. The drivetrain was equally tank-like. Axles, differentials, and drive shafts were built to absorb shock loads without failure. Engines were detuned for longevity, allowing thousands of hours of operation between rebuilds. Operators routinely overloaded the Franklin 170 far beyond its rated capacity, yet structural failures were rare. When repairs were needed, they were mechanical and straightforward. Many Franklin 170 skidders remain in service today, especially in rough, remote terrain, where modern machines struggle with electronic failures. Their survival proves that in logging, steel thickness and mechanical simplicity matter more than technology. The Franklin 170 wasn't elegant, but it was unstoppable. Number 5. Tree Farmer C6 Skidder. The Tree Farmer C6 skidder was never meant to be refined, fast, or efficient. It was built to survive brutal logging conditions where failure was not an option. In the 1980s, when log sizes were larger and terrain was harsher, Tree Farmer designed the C6 with one guiding principle: mass equals durability. Everything about the machine reflected that belief. From its boxy silhouette to its thick steel frame, the C6 looked more like a rolling bunker than a piece of forestry equipment. The engine in the Tree Farmer C6 was tuned for torque, not speed. Low RPM operation meant reduced heat, lower internal stress, and a dramatically longer service life. Loggers could hook onto massive timber and pull uphill without worrying about engine strain. The drivetrain was equally overbuilt, featuring heavy axles and driveline components capable of absorbing sudden shock loads when logs snagged on stumps or rocks. These machines were routinely pushed far beyond their rated capacity, yet frame failures were extremely rare. The cable winch system on the C6 was one of its strongest features. Thick drums, oversized gears, and powerful brakes allowed the machine to pull and hold enormous log turns safely. Hydraulics were simple and slow, operating at conservative pressures that reduced hose failures and seal wear. The articulation joint, a common failure point on many skidders, was massively reinforced, allowing years of twisting under load without cracking. Many Tree Farmer C6 skidders from the 1980s are still working today with rebuilt engines but original frames. Their continued operation proves that excessive weight and steel thickness, often criticized today, were exactly what logging machines needed to survive long-term. Number 6. Clock Ranger 668 Skidder. The Clock Ranger 668 is a perfect example of old-school mechanical honesty. Built in the 1980s, this cable skidder was designed with minimal complexity and maximum strength. Clock engineers understood that logging environments destroy delicate systems, so they avoided unnecessary technology and focused on proven mechanical solutions. The result was a skidder that could be abused daily and still show up for work the next morning. The Ranger 668 featured a mechanically driven transmission and heavy axles that could absorb shock loads without damage. When logs suddenly stopped or shifted during a pull, the drivetrain handled the impact instead of transferring it to fragile components. Engines were detuned and understressed, allowing them to run for thousands of hours with only basic maintenance. Fuel efficiency was secondary to reliability. The winch system was a standout feature. Built with thick steel housings, oversized gears, and powerful braking systems, it could pull massive timber without slipping or overheating. Operators trusted the Ranger 668 because it behaved predictably. There were no electronic surprises, no sudden shutdowns, and no sensor faults. If something went wrong, it was visible and repairable with hand tools. Many Clock Ranger 668 skidders remain in service today, especially in small and private logging operations. Their survival highlights a truth modern equipment often ignores. Machines built with simple mechanics and oversized components age far better than technologically complex designs. Number 7. Timberjack 380 Grapple Skidder. The Timberjack 380 grapple skidder became a favorite in the 1980s for operations handling large timber with grapple systems rather than cables. Timberjack's reputation for durability carried over strongly into the 380, which combined controlled hydraulic power with a heavily reinforced frame. Unlike lighter grapple skidders that sacrificed durability for speed, the 380 prioritized long-term survival. The engine was tuned conservatively, delivering strong torque without excessive RPM. This allowed the machine to move heavy log bundles efficiently while minimizing engine wear. The articulated frame was heavily reinforced to resist cracking under repeated twisting loads, a critical advantage in rough terrain. Axles and driveline components were designed to handle constant shock without fatigue. Hydraulics on the 380 were powerful but not extreme. Operating pressures were balanced to reduce heat buildup and extend component life. Grapple arms were thick and heavily pinned, resisting bending even when overloaded. Timberjack understood that loggers would exceed rated capacities, so they built the machine accordingly. Many Timberjack 380 skidders from the 1980s are still active today, often with upgraded hoses and rebuilt engines but original frames and grapples. Their longevity proves that controlled power and conservative engineering create machines that can work for decades without structural failure. Number 8. John Deere 540D Skidder. The John Deere 540D may not have been the largest skidder of the 1980s, but it earned a reputation for punching far above its weight. Designed for tighter forest environments and selective logging, the 540D was built with the same durability mindset as larger Deere machines. Engineers knew operators would overload it, so they reinforced it accordingly. The engine delivered steady, reliable torque, allowing the machine to pull surprisingly large log turns. Cooling systems were well designed, preventing overheating during long shifts. The drivetrain was rugged and forgiving, capable of absorbing sudden load changes without failure. The frame, while smaller, was heavily reinforced at critical stress points. Hydraulics were simple and reliable, with minimal electronics and easy field serviceability. Operators appreciated how easy the 540D was to maintain, often keeping machines running for decades with basic repairs. Parts availability also played a role in longevity, allowing these skidders to stay productive long after others were scrapped. Many 540D skidders from the 1980s are still working today, especially in private forestry operations. Their survival proves that toughness isn't about size, it's about how a machine is built. Number 9. Caterpillar 525 Skidder. The Caterpillar 525 skidder was one of those machines that didn't look flashy, didn't promise innovation, and didn't care about comfort, but it earned respect the hard way by surviving decades of abuse. Introduced and widely used during the 1980s, the Cat 525 was built for loggers who needed a dependable mid-size skidder that could handle oversized timber without constant repairs. Caterpillar approached the 525 with a conservative industrial mindset: make it strong first, then make it work. At the heart of the 525 was a naturally aspirated Caterpillar diesel engine tuned for torque rather than horsepower. This allowed the skidder to pull heavy log turns at low RPM without overheating or stressing internal components. The engine's simplicity made it extremely tolerant of poor fuel quality and inconsistent maintenance, common realities in remote logging operations. Many engines ran for tens of thousands of hours with multiple rebuilds, yet the core blocks remained intact. The drivetrain was pure Caterpillar DNA: heavy axles, oversized differentials, and a transmission built to absorb shock loads when logs suddenly stopped or shifted. The frame was thick and rigid, particularly around the articulation joint, an area Cat reinforced heavily, knowing it would face constant twisting forces. Forestry guarding protected hoses, fuel lines, and vital components from falling timber and debris. Hydraulics on the 525 were slow but brutally reliable. Lower operating pressures meant less heat, fewer blown hoses, and longer seal life. Operators often complained that newer machines were faster, but few could match the 525's ability to survive day after day of abuse. Even today, Cat 525 skidders from the 1980s are still working in selective logging and private forestry operations. Their survival proves that Caterpillar's old-school approach, build it heavier than necessary, was exactly right. Number 10. Timberjack 560 skidder. The Timberjack 560 is widely regarded as one of the most powerful and durable skidders ever produced in the 1980s, and it was built specifically for one purpose: pulling massive timber that smaller machines simply could not handle. Everything about the 560 was scaled up: engine, frame, axles, winch, and weight, making it a true heavy-duty skidder designed for the toughest logging environments. Powering the Timberjack 560 was a large, low-revving diesel engine tuned to deliver enormous torque. Rather than chasing speed, Timberjack focused on controlled pulling power, allowing the machine to drag oversized log turns uphill without overstressing the drivetrain. Cooling systems were oversized to handle long, hard pulls without overheating, even in hot or high-altitude environments. The frame of the 560 was massive, with thick steel sections designed to resist fatigue cracking under years of twisting and shock loads. Axles and differentials were built to industrial standards, capable of absorbing sudden impacts when logs snagged on stumps or rocks. The winch system was one of the strongest Timberjack ever produced, featuring thick drums, heavy gears, and powerful brakes that could hold massive loads safely on steep slopes. Hydraulics were simple and durable, operating at conservative pressures to reduce heat and wear. The articulation joint was heavily reinforced, allowing the skidder to maneuver in tight forest conditions without structural damage. Many Timberjack 560 skidders from the 1980s are still working today, often with rebuilt engines but original frames and winches. The 560 stands as the final proof of why 1980s skidders endure. When a machine is designed specifically for worst-case logging conditions, it doesn't just last, it becomes irreplaceable. Those were the skidding legends of the 80s. Machines built for punishment, not comfort. They dragged impossible loads, survived brutal conditions, and earned the trust of loggers worldwide. Even today, they prove that true strength doesn't come from technology. It comes from steel, torque, and fearless engineering. Which of these skidders do you think is the toughest ever built? Drop your answer in the comments. I read every one. If you respect old-school logging machines, hit like, subscribe, and share this video with a fellow timber lover. Thanks for watching, and until next time, keep the winches tight and the legends pulling.